name is Samuel Daishimi. Welcome to my database development presentation. Today, I will be walking you through a complete database solution for a database cloud management system. This project demonstrates the understanding of database design principles, normalization techniques, SQL implementation, and complex query development. Welcome to my presentation as well. Let me scroll down to show you what I did. Yes, scenario selection and description. Uh, the basketball club system is designed for a community basketball club which is called Hills that manages multiple teams across different age groups like under 12, under 16, and senior team as well. So the system needs to handle four main areas, four main points as the purpose of our database. First one is to register and track player profiles across multiple age group teams. Second is to manage coaching staff and their assignment roles with each team. Third is to schedule and record match fixtures, opponents, venues, and final results. Fourth is to track individual player statistics per match, like rebounds, points, and assists. Fifth is record and manage training sessions and player attendance. The key challenge this database solves is eliminating data duplication and maintaining data integrity across these interconnected activities. There are so many users in this database. As this table shows, there is club administrator who will manage overall data entry, player registrations, and team setup. There is head coach, which views team rosters, match schedules, and player statistics. Assistant coach, his responsibility is logs match results, track training attendance. Player is his responsibility is review personal statistics and upcoming fixtures. He will not be able to edit something in this database. Second section is identification of database entities. In database entities, the following 6 entities were identified by analyzing the real-world activities of our basketball club. Each entity presents a distinct, independently meaningful concept that requires persistent storage. Entities are players. Players entity stores personal details for each registered player, including their name, age, position, and jersey number. Coaches entity stores information about the coaching staff, including their role and contact details. Teams entity represents its age group squad, under 12, under 16, and senior team. Matches entity records every fixture with the opponent, venue, date, and final score. Player stats is a junction table that captures individual player performance in each match, points, rebounds, and assists. training session entity logs each practice session with its date, location, and type. And finally, training attendance uh, links players to training sessions, records whether they were present, absent, or late. Each of these entities represents a distinct real-world concept that requires independent storage. Fourth section is normalization process. Now, let's look at how I normalized the data to third normal form. I started with an normalized form. Imagine a single table with repeating groups like this. You can see here that player information would repeat for each match, creating massive redundancy and update anomalies. Like as you see, this table is unnormalized. Let's go to first normal form. In first normal form, I eliminated the repeating groups. Each player's performance in each match gets its own row. The composite key of match ID and player ID uniquely identifies each record. All values are now atomic, no multivalued series. This is the table of first normal form as you are seeing here. Moving to second normal form, I identified and removed partial dependencies. Attributes that depend only on match ID like the date, opponent, and location were moved to a matches table. Player attributes like name and position were removed to players table. Only the performance statistics, points, rebounds, assists remained in what became the player stats table because these depend on both the match and the player, as you are seeing here. Finally, for third normal form, I eliminated transitive dependencies. I noticed that team information didn't directly depend on the match, it depended on which team played. So I extracted a team's table. Similarly, coach information depended on the team, not the match. So I created a separate coach table. Now the result is seven fully normalized tables with no data duplication and full referential integrity. As you are seeing here are all the tables normalized in a third normal form, as you see here. Let's jump to scenario called entity relationship diagram. The entity diagram below describes all entities, their attributes, primary keys, undefined foreign keys, and cardinalities, as you are seeing here. Let me walk through the key relationships. As you are seeing here in this diagram, each coach can manage multiple teams. This is one-to-one relationship. Each team has many players, but each player belongs to only one team. Another one-to-many relationship. Teams plays multiple matches, and each match is played by one team. The relationships between matches and players is many-to-many. A player can play in many matches, and each match has many players. This is solved through the player stats junction table. Similarly, players and training sessions have many-to-many relationships. It's solved by training attendance table. All primary keys are underlined and foreign keys are clearly marked. This diagram shows how or several entities interconnect to create a complete normalized database structure. Let's go to data dictionary. The data dictionary documents every table and attribute in detail. For each column, I have specified the data type, size, constraints, and a clear description of its purpose. For example, in the players table, this players table on the screen, you can see the player ID as integer, it's the primary key, it's not null, and auto increment. The edge field has check constraints, ensuring all players are over 5 years old, which makes sense for a basketball club. These numbers are unique per team, preventing duplicate numbers. Foreign key relationships are clearly documented. Team ID references the team's table. I have applied similar detail to all 7 tables covering 37 attributes total with appropriate constraints, including not null, unique, check constraints, and default values where applicable. Those tables are reference of the players table. Also, there is coaches table. There is teams table, as you are seeing here. There is table which is called the matches. There's another table which is in player stats. There is a table which is training sessions, and the last one is training attendance, which is the same as the first one. Uh, the section number 6 is database implementation in SQL. So we can say is SQL implementation. Now let me show you the actual database implementation. I have created all 7 tables using SQL. Create table statements with full constraint definitions. As you are seeing here, this first query is create database, which is called the basketball club. Create table coaches. The table which is called the coaches is created by all these SQL query. And create table teams is teams table. This is players table, and this query is to create matches. This query is to create player stats. This query again is to create training is in the sessions table. This query is to create training attendance table. As you are seeing, and here you can see 7 tables created in the basketball club database. Now let me show you one table creation statement. Let me choose to show you a table which is called, for example, matches. There's match ID, team ID, which is integer, not null, and it increment. Match ID is a primary key. Match date and result, location, opponent, club score, opponent score, and we define the primary key in table level as you are seeing. And foreign key is team ID from teams table. Here's the players table populated with data. You can see we have players across different age groups, realistic names, positions, contract information, and team name they played. So in the section number 7 is, oh, let me show you the how I inserted the data in players table. Okay, in teams table. Let me show you how I inserted the data in teams table. I use the insert into statement. The table is teams. There is the columns which is coach ID, team name, and age group. Values, the one if value one is senior men, which is age group is senior. The second is senior women. Age group is senior as well. Third, under 18 boys. Age group is U18. Under 16 boys. Age group is U16. Under 12 mixed. In mixed, I mean is boys and girls. So the age group is U12. And other tables I started using that query, which is statement, SQL statement, which is called insert into statement. This section is called query demonstration or query development, or combined are 30 SQL queries. Basic first age, basic select queries. Let's start with a basic query. This retrieves all points guards from the players table using a simple where clause. And here are the results. You can see 5 players who plays in each position. Select all from players or 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 values in the stored in the table, which is called players, will be retrieved. Second, query number 2 is show only match date, opponent, and result. Select match date, opponent, result from matches. We don't select all entity or attributes from matches entity. We select where what we want to view, not all at the same time. Filter players by position. Retrieve only players who play point guard or PG. Select players. Select player ID, first name, last name, jersey number from players where position equal point guard. Yes. Query number 4 is sort players by age descending. Select first name, last name, age, position from players ordered by age descending. You can also use ascending from youngest to the oldest. Here is from oldest player in the entity to the youngest in the entity. Query number 5, limit to top 5 matches. Select match ID, match date, opponent, result, club score, opponent score from matches ordered by match date descending. Limit 5. Limit restricts result set combined with order by gives most records. B is aggregate functions. Query number 6. Count total players. Purpose is count how many players are registered in the club. Select count all as total players from players. Yes. Query number 7 is sum of club scores. Purpose is to calculate the total points scored by all club teams across all matches. This query is we use sum statement. average points, there is maximum points as well. Remember, we are in a aggregate function where we use round, we use sum, we use max, and count. C is filtering with between. In SQL, in MySQL, we can filter data by using where, by using clause, by using between clause. Purpose and use and or to find players under 25 who play point guard or central guard. Select first name, last name, age, position from players where age is less than 25 and position is player guard or position is central guard. Matches played in April 2024. We are still using between in this query as you are seeing. Players in senior teams, we are also using join. Players in senior teams, purpose use in to match players belonging to senior men and senior women. Select P as first name, P, last name, T, team name from players, P. Join teams, T on P. Say team name on players equal team dot team ID, where team name in senior men and senior women. Remember, the purpose was to use the in to match players belonging to senior men or senior women. Let's jump to joining queries or joins. There is inner join, left join, and right join. Combine join is to combine players by using this example is to combine players and teams to show each player's team name. As you are seeing here, we use to combine players and teams. Yes. Left join, as you in inner join you combine or left join you combine in left side, right join is vice versa. Yes. Let's jump to nested subqueries. Subquery is where player who scored above. Subquery in where by using this example, we are going to find players whose match points exceed the overall average. By using this query, you are seeing this query uses a subquery to find players who scored more points than average across all matches. The inner query calculates the average points, and the outer query filters for players exceeding that average. You can see players like Carlos and Ethan who had exceptional performances. As you are saying, you can retrieve them. Let's jump into data modification queries, update and modification. Here is on an update query modification. Carlos' phone number. The query executes successfully, affecting one row. Let me verify the change. And here we can see the phone number has been updated correctly. Let's go to advanced queries. Finally, let's look at a complex query using multiple SQL functions. This query uses concat to combine first and last names, year and month, to extract date components and round to format averages. It groups player statistics by player, team, and month. The results show comprehensive player performance data with properly formatted names and rounded statistics, exactly what a coach would need for performance analysis. These queries are advanced queries, having and some more keywords as well. Mm, Additional queries. You should mention so all that the queries are completed in the previous section. I have also implemented queries for left join to show matches even without player stats. Left right join for all coaches including those without teams. Having close to filter grouped results. Top n queries to find the highest score. Complex nested subqueries comparing team performance against their own averages. Delete operations with subquery conditions. Multi-row insert statements. So, to summarize, this project demonstrates a complete database development life cycle. Uh, I identified a realistic scenario requiring structured data management, analyzed the requirements, to identify 7 distinct entities, applied the normalization principles step by step from an normalized form through third normal form, created a comprehensive edit showing all entities, documented every attribute in a detailed data dictionary, implemented the database with full SQL DDA, and populated it with realistic sample data, and finally developed started vast queries covering all required operations. This system provides a solid foundation of a basketball club which is called Hills to manage their players, teams, matches, and training activities with full data integrity and no redundancy. Thank you for watching. The full document is available in the submitted PDF, including all SQL code and query explanation. Thank you.